Today we are going to see 12th chemistry. The topic name is electrochemistry, and into that just we are going to see about electrochemical cell today. Okay. So first, what is electrochemical cell? Okay. So this cell which converts the chemical energy into electrical energy as well as the vice versa also will be possible, that is to convert electrical energy into chemical energy. Okay, and this electrochemical cell consists of two separate electrode with the electrolytic solution, that is two separate electrodes with the electrolytic solution. Okay, and same way, if you take a electrochemical cell, it consists of two separate electrode and that should be dipped in the particular electrolytic solution. And if you take the electrochemical cell that has two types of electrochemical cell. One is a galvanic cell, or we can call it as a voltaic cell. Okay, and second one, electrolytic cell. Okay, there are two types of cell. One is a galvanic cell and a electrolytic cell. The galvanic cell that converts chemical energy into electrical energy. Okay, chemical energy into electrical energy, that will be a spontaneous process. And the electrolytic cell converts electrical energy into chemical energy. Okay, and today you are going to see about a galvanic cell. So first, we have learned in 11th standard about this cell. So the cell process, whenever if you are taking a zinc metal strip, okay, if you are taking a zinc metal strip, if the strip is dipped in copper sulfate solution, now what happens? So whenever the metal strip is dipped in copper sulfate solution, you can write that equation. Zinc is dipped in a copper sulfate solution. There is a possibility of a reaction. The zinc is converted into zinc sulfate and copper should be deposited, and this will be in the solid state and this in the aqueous solution. Okay, and this should be on the aqueous solution. Okay, now what happened? From this we can take, this is a redox reaction in which the zinc is getting oxidized into Zn2 plus, and whereas here the copper 2 plus is reduced into copper, Zn2 plus is oxidized into Zn2 plus. This is an example for a redox reaction. Okay. And whenever if you are taking the metal strip dipped in copper sulfate solution, this reaction will occur, but whenever the energy released, that is the energy released to the surrounding as heat. Okay. So what happened to that color means the color of the copper sulfate solution, blue color, that will be fade when zinc metal strip is dipped into the copper sulfate solution. The same way the copper should be deposited on the zinc electrode. This is a reaction occurs in the redox process, okay, and the energy released in the form of a heat, but there is no conversion. So in the same manner, if we perform this kind of reaction that occurs in a separate container, that is, if you are taking one half cell as a zinc and one half cell as a copper, there will be same type of reaction there also. So here also zinc is oxidized into Zn plus 2 and removal of 2 electron, whereas Cu2 plus reduced into copper. The same type of reaction, but here the energy released that will be converted into electrical energy. That will be converted into electrical energy. So to explain that galvanic cell, next I am going to take Daniel cell as a good example, where the oxidation and the reduction also taking place in the same manner. Next we are going to discuss about a Daniel cell. Okay, next we are going to see the Daniel cell. It's a good example for a galvanic cell. So what is happened in the cell means, just as it is, as I said before, we are going to take a separate container with the electrode and dip it in the electrolytic solution. Okay, so first one, if you take anode of cell, if you take an anode of cell, what should be the anode? You know that metallic zinc strip dipped in electrolytic solution zinc sulfate, that is zinc sulfate solution. Okay, now I will side by side I will draw the metal with the electrolytic solution compartment. To one half cell, just I am going to construct like this. Just we have to take one beaker. Okay, just next we are going to dip the zinc electrode, that should be acting as a anode, negative sign, and here the electrolytic solution just we are taking as Zn and that will be split up into Zn plus 2 and the SO4 2 minus. This is one half cell, that is anodic compartment. Okay, and next take a cathode of cell. Okay, so here copper strip of copper, that should be dipped in copper sulfate solution. Okay, the next I am going to take another one of cell, that is cathodic compartment. I am going to place a strip of copper that will be acting as a cathode. Okay, here I am going to take a electrolytic solution copper sulfate, and that will be split up into ions SO4 minus and Ce2 plus. So just we are constructing one half cell with the another half cell, because the electrochemical cell made with a two half cell. Okay, one is cathode and another one is the anode. Okay, next how will you join the half cell? Joining of half cells. Okay, here first I am going to connect the two electrodes. So just the two electrodes are connected through wire by to switch under the load. So here we are taking a load as voltmeter. Okay, so first let us connect the two electrode. So the two electrode, just by using of a wire I am going to connect the two electrode by using a voltmeter. Okay, like this. This is called a external circuit. Okay, and next just we are going to connect the two electrolytic solution, that is two electrolytic solutions are connected by using of a inverted U-shaped tube. Inverted U-shaped tube, that is known as salt bridge. This is known as what? A salt bridge. Just I am going to take one inverted tube, that should be connected. Okay, that should be connected by using of a U-tube, that is named as a salt bridge. Okay. Now what does this salt bridge consist of? The salt bridge consists of a agar-agar gel. Okay, that should be mixed with the electrolyte. Mixed with the electrolyte. The electrolyte we can take it as a KCl, or you can take it as a Na2SO4. Okay. So if you are taking a salt bridge consists of two substance. One is agar-agar gel, and second one we can take it as a electrolyte KCl, and or we can take it as a Na2SO4. Okay. Now what happened to the salt bridge? So here the ions present in the salt bridge, that is ions present in the electrolyte. Okay. Ions in electrolyte do not mixed with the ions in off-cell solution, that is taken as a electrolytic solution. Okay, if I am taking, suppose if I am taking here KCl, means the ions of electrolyte K plus and Cl minus do not mixed with the ions present in the anodic compartment or a cathodic compartment, that means electrolytic solution. And the same way, the solution whatever may be the agar-agar gel or the electrolytic solution, just it is not poured out from the salt bridge. The solution in salt bridge, okay, that is not poured out. Only it will allow the ions will, only it will allow the ions to pass through. This is the construction of a electrochemical cell. Just we are seeing about anode, cathode, and how can you connect the joining of the off cell. Next we will see what happened. So whenever if I am taking the two off cell, that should be connected by using of a voltmeter. So as soon as the switch closes a circuit, okay, as well as the switch, whenever the closes a circuit, what happened? The movement of the electron from the anodic compartment to the cathodic compartment, this is due to the occurring of a redox reaction. That will be a spontaneous reaction. Okay. Next we are going to see about what type of a reaction that occurs in the two off cells. You can take this electrochemical cell. Let us discuss anodic oxidation. Okay, what happened to the anode? We know that the anode we are taking as zinc. Okay, so at the anode the reaction occurs oxidation. So at the anode, oxidation reaction will take place. Okay. Now what happened to the zinc electrode? We are taking a metallic zinc strip. So now what happened? The zinc is oxidized into Zn 2 plus ion. That will be converted into Zn 2 plus. Okay. Now here what happened? Whenever the Zn 2 plus formed, okay, here this is Zn metallic strip. Okay, this will undergo oxidation and it forms a Zn 2 plus ion. That Zn 2 plus ion enter into the solution. In the same way, the formed 2 electron enters into the metallic zinc, and the 2 electron that will be comes out. Okay, the 2 electron that will be comes out, that will be flow through the circuit, and that will be enter into the cathodic compartment. Okay, so here what happened? The zinc is converted, that is zinc is undergo oxidation, converted into Zn 2 plus ion. The Zn 2 plus ion enters the solution, and the electrons flow through the circuit and enters into cathodic compartment. Okay, and here there will be liberation of the electrons. That is, the electron will flow from one compartment to the another compartment. So here the electrons are liberated. So hence the compartment will be a negative. Okay, compartment. Negative sign will be appeared in the anode. And the same way, what happened to the cathodic oxidation, that is cathodic reduction. Okay. So whenever the electrons flow through the circuit and that will be enter into the cathodic compartment, the entered electron that will be reacted with the ions which is present in the cathodic compartment, copper 2 plus, that is reduced into copper. Okay, in the same way, okay, here the Cu2 plus take a electron from the anodic compartment and that will be converted into the copper. Okay, the formed copper that is deposited on the electrode. So here the Cu2 plus ion and the copper electrode, the 2 electron that should be received, okay, copper 2 plus ion, and that will be converted into copper and that is deposited on the cathodic part, okay, cathodic electrode. And same way what happens here means, here we are receiving the electron, that is just we are consuming the electron, the cathodic compartment consuming the electron. So it should be acting as a positive part. Okay. So this is separate compartment. And next, what happened to the salt bridge? So whenever the electron flows from one compartment to the another compartment, there will be oxidation and reduction taking place simultaneously. Now what happened means, here at the anode, whenever the concentration of the Zn2 plus ion increases, the anodic compartment concentration of the Zn2 plus ion concentration increases. Okay, and sulfate ion concentration that should be decreases compared to the Zn2 plus. Okay, so the concentration of a Zn2 plus ion increases in the anodic compartment, So that becomes a positive part, positively charged will be increased. And the same way, if you move to the cathodic compartment, it receives the electron. So here the concentration of a sulfate ion will be increased. Concentration of a sulfate ion increases. Okay. So in the anodic compartment, the concentration of a Zn2 plus ion increases. In the cathodic compartment, the concentration of a sulfate ion increases. Whenever if you take the electrolyte, that will be a neutral. In order to maintain the neutrality, because in both compartment the concentration of a one ion increases. So here the positive ion increases, so this becomes a positive compartment, and here negative ion increases, that becomes a negative compartment. So here the neutrality we want to maintain. So in order to maintain the neutrality, what happened? The salt bridge ions. Okay, so here the salt bridge we are taking a ion, the electrolyte consisting of a K plus and a Cl minus ion. So to maintain the neutrality in both compartments, the Cl minus ion will move towards the anodic compartment, and the positive K plus will move towards the cathodic compartment. Okay, and the maintaining of a neutrality will be maintained by the movement of the ions. That too, the negative ion will move towards a negative electrode, the positive ion will move towards a positive electrode. So this is a cell setup that comes under a electrochemical cell. Just we are taking a Daniell cell as an example. Okay, next we are going to see about completion of a circuit. Okay, here what happen? The electron will flow from one compartment, that is electrons flow from zinc electrode to copper electrode, that is compartment. The same way the ions of, that is Cl minus ion, move towards anode. Okay, and this next the K plus ion from the salt bridge, the electrolyte, move towards a cathode, and this will complete the circuit. That is a movement of the electrons from one compartment to the another compartment, that will be neutralized by the movement of the ions from one part to the another part. That is from Cl minus ion move towards the anode and K plus ion move towards the cathode. This will complete the circuit. This will complete the circuit. Okay, and next we are going to see about the conception of a electrode. What happened to the electrodes? Okay, so whenever if I am taking an anode, the metallic zinc, that will be undergo oxidation, and the same way that is converted into Zn2 plus ion. So whenever there is conversion of a Zn2 plus ion, here the mass of the zinc, that should be decreased. Okay, so mass of zinc is decreased. Okay, in the same way, the two electron pass through the another compartment, and the copper will be what? Will be reduced. So here the mass of the copper will be increased, because the copper will be deposited. So the mass of the copper will be increased. Okay, how can you maintain the Daniell cell, the flow? Okay, whenever the cell will complete until entirely the zinc has to be converted into Zn plus 2. That is one way to complete that. So fully we have to complete the conversion of a zinc, that should be completed fully into Zn2 plus ion, or completion of a copper plus 2 ion, okay, that should be entirely deposited as a copper. Okay. So whenever the entire we have to transfer zinc as Zn 2 plus ion, or entirely we have to what, convert copper 2 plus ion converted into copper, okay, until the reaction over. This is called the consumption of the electrode. We are talking about in terms of a mass, because whenever the flow of 2 electron in the cathodic compartment will convert copper 2 plus ion into copper, and that should be deposited. So generally the mass will be increased. Okay. So in this section just we are taking an electrochemical cell, and we have discussed the types of electrochemical cell, that too galvanic cell. So galvanic cell is made up of two half cell. The two half cell means one half cell consisting of one electrode with the electrolytic solution, and another half cell consisting of another one electrode with the electrolytic solution, that should be dipped, and the two electrode that should be connected externally by using of a voltmeter, and same way the anodic and cathodic compartment, the solution that should be connected by using of a salt bridge. And we have discussed what is salt bridge substance which is present, and the ions present in the salt bridge, how balance the neutrality in the solution. Okay, that's all. Thank you.